Okay, we are going to talk about converting from polar coordinates into rectangular coordinates. So it's like we're given an r and a theta. So let's say I'm given this r and theta, and I'll say like this is my r here, and we'll say this is my theta. And what I actually want is this ordered pair here in terms of x and y. I want the rectangular coordinate for that ordered pair. Okay, so what we do here is we drop this down and make a right triangle, and the x coordinate I want is actually down here, and the y coordinate is actually this over here. Okay, and this is my theta. And so now we can use the right triangle trig, right? I got that the cosine of theta is x over r. It's the adjacent over the hypotenuse. Okay, and so that means x is just r times cosine theta. And then my sine is the opposite over r. So that the sine theta here would be the y over r. Okay, and so my y is just r sine theta. Okay, and so it's very easy. If you have an r theta, a polar coordinate, then you just take r times the cosine of theta to get the x coordinate, r times the sine theta to get the y coordinate. And so one way you can think of it is if you have r theta here, and this is the polar, and you want to convert it over here into a rectangular, then the rectangular would just be r cosine theta, r sine theta. And that would give you your rectangular coordinate down here. Okay? So let's just do a few examples here. So let's say I have, we'll say 10 pi over 3. Okay? So, pi over 3, we'll say like this is 10 here, that side is 10, and then this is pi over 3. And I want this xy ordered pair here. Okay, so my x is just 10 times cosine of pi over 3. Maybe I can zoom in on this a little bit. And then the y is 10 times the sine of pi over 3. That is blurry. Let's see if I can focus that a little bit better. And so pi over, the cosine of pi over 3 is 1/2. So this would be like 10 times 1/2, which would just be 5. And then sine of pi over 3 is square root of 3 over 2. So 10 square root of 3 over 2. And so this would be 5 square root of 3. And so this ordered pair here would be 5 and 5 square root of 3. And I guess we could find what that would be as a decimal. 5 times the square root of 3. That's like 8.66. So, which is approximately 5 and 8.66. And so that kind of makes sense. That's what this point would be here. So if this were 10 and that were pi over 3, that would be your ordered pair. Okay? So, what's really nice is that this works for any of the quadrants. It doesn't have to be this one. This is what makes sense with our right triangle, but because of the way the unit circle works here, so I could have some weird ordered pair. So let's just say it's like 345, and then I'll give a radian, not in terms of pi. We'll just say like 4.65. Okay, so just so you remember, 3 pi over 2 is approximately like 4.7 something. Let's see, 3 pi over 2. It's like, yeah, 4.71. 4.71. So this is really close to that, right? And then, so that's the angle. And then the R is like 3.345, right? And so what I can do is I can just put these in my calculator. This would be 345 times the cosine of 4.65, and I just have to make sure that I'm in radians. We've been using degrees a lot with the law of sines and law of cosines in the last section. So make sure it's in radians, and mine is. So what I get here is like a negative 21.5, and then my y, 345 sine of 4.65. So 345 times the sine of 4.65. And I get like negative 344.3. So that's my y coordinate, this is my x coordinate, and you can see that that actually does make sense for this. Negative 21.5, negative 344.3 for this. If that were 345 and that were my angle, that is about what you would get here. So this will work straight. Just put in R, put in the theta, whatever they are, just plug them in and you calculate the angle. You calculate the rectangular coordinate, just like that. So that's converting from polar coordinate to rectangular coordinate. And so in the next video, we will talk about converting from the rectangular coordinate to the polar coordinate.